Okay, the problems from the practice test. The first two, complex fractions. We need to use that little trick I taught you to get rid of all the bottoms. I want to point out this first one. The LCD between these two would be 6x, right? Least common multiple of 2 and 3. Here it's 12. So that's what I need to use to get rid of all of them. I'm going to put 12x on the top of every one of the fractions. I mean, this is the first step. This is the strategy. It is very important when you do this for me on your test, you want to show me the work. I want to see that you cross the bottoms out and divide them in. 12 divided by, now it's 12x, right? So that x is not getting crossed out. 12 divided by 2 is 6, and the x is still there. Now I'm going to do 3x into 12x. This time the x's do cross out. 12 divided by 3 is 4. So this is what you multiply by. Here, again, you have 12x divided by 4x. That leaves you with a 3. Here you have 12x divided by 3x. That leaves you with a 4. Right? So now I'm going to multiply everything together. You cross out all the bottoms. This is the move. I get 30x on top, right? 6x times 5. 4 times 5 is 20. I actually meant this to be a 10. I messed up. I forgot to change it. This should be a 40. I screwed up, but I'm going to do it the way I had it. 3 times 3 is 9. Take away 1 times 4 is 4. So that's a 5 on the bottom. So let's cheat. Right? 9 minus 4, 5. Just to save space. 30 divided by 5 is 6. The x goes along for the ride. 20 divided by 5 is 4. You must do this, right? This 5 goes into both of them. So you divide them out. There you go. Don't do nothing else. You think you could factor out it too? Don't do that. A solver would do that. A human being wouldn't do that, right? It's 6x plus 4. You just leave it alone. They're not like terms. You can't combine them. Now the next one, there aren't any numbers on the bottom, and one of them doesn't even have a bottom. That's fine. It doesn't need a bottom. You're still going to give it the product when you get to it. So you want to multiply them all by x squared, right? Because you have x, x2, x2. You need something that's going to cross them all out. So put x squared on each one. Again, this isn't optional. This is what you must do. You're not making the bottoms the same. You're not combining anything. You're using a trick. So here, when you cross out x2 by x, you're left with an x. Here, they just cross out completely, right? X squared over x squared is 1. Cross out completely. There's nothing to cross out. You get 36x squared there. It's quite simple. Now, a lot of people had trouble here. Let's see, people who were showing me during class, that's 6x plus 5, right? 5 times 1. Now, at the bottom, you have 36 times x squared. And then you have minus 25. Now, people did have issues factoring the bottom. I mean, people started crossing out here. They put 6 into 36, 5 into 25. This is a big mistake. You can't cross out in that manner. You must factor the bottom. This is a difference of perfect squares. So you know what? I'll do it underneath. So the top's going to keep it alone. Leave it alone for a minute. The bottom, right? Something times itself to make 36x squared. That's 6x and 6x. And then something times itself to make 25. One guy gets the plus, one guy gets the minus, right? Difference of perfect squares. Something times itself. It's like basically something in its conjugate, right? They're exactly the same except the signs are different. Now you're going to cross out. Here's the huge trap. When you cross these out, you don't get 6x minus 5, right? When you divide something by itself, you make a 1. This dude is on the bottom of the fraction. So after you cross out, he is still left on the bottom of the fraction. I see that mistake all the time. That people cross them out and then they just get 6x minus 5. But it's 1 over 6. There's a big difference. There's a big difference between 2 and 1 over 2. So you got to put that 1 on top or lose a point. All right, so those are the first two that I'm doing. All right, so on number 2, I'm going to do a bunch of these and I try to go through them as quickly as I can. You have negative power. Negative powers are not defined. You have to flip that power over and make it positive. So this is your first step I have to see. I mean, I don't know why this, a lot of people had trouble with this on a quiz. Now you just do 4 times 4, which is 16, right? 4 squared. Flip it so the power makes plus. do the power. I mean, this is about as straightforward as it gets. I don't know what else to say there. Now here, remember, the bottom number is the root. 3 means that it's a cube root. So you need to do the cube root of 125 first. Now again, solvers have a lot of fun with these. They do them in real crazy, weird-ass, off-the-wall ways. That's not, you got to do what I showed you. Take the cube root of 125. So you're looking for what number times itself. 3 times is 125. I mean, come on, the number ends in a 5. So what the hell else could it be? 5 times 5 is 25. And then 25 times 5 is 125. So the cube root of this is 5. Nothing too crazy. And then you got to square it. Right? Do the root first, then square the number. 5 times 5, 25. There you go. Pretty easy. Okay, the next 3, these are the ones that you guys were asking to see. So again, negative power. You must flip it over, make the power positive, get 1/2. Now, you have to know what the heck the 1/2 power is. So this is the opposite of squaring. So this must be square root. So you're going to have to do the square root of 36. But the square root of 36 is 6. So boom, done. So flip it so the power becomes plus. Put the root there, and then do the root. No problem. I must see all of this. If you jump from here to here or here to here, I'm going to be very unhappy. I want to see each step in the process. The first step is to make the power plus, replace it with the root, and then do the root. Now this one, again, the 2 on the bottom means square root. What does the 3 mean? The 3 means nothing. It's the regular power. It's the third power. However, even though we know now that this is the fake-ass imaginary number 8i, this is still undefined. This is not something you can do, right? It's still not a real number, right? Our universe consists of real numbers. So this nonsense still, we're going to still write BS. I mean, yeah, we figured out a way to do it as an imaginary number, but this is not, it's not defined in this problem. So put the BS there. I mean, you want to put 8i and cube it. Don't do this. All right, this isn't what I want here. Now this one, people ask me to do it. I think maybe you got freaked out from the radical 7. Ignore that negative for a second, right? Because it's just -1 times the power, right? You don't hop the fence with the power on, right? You must do the power, order of operations, do the power, then you do multiplying. That's where that negative really is. But I told you that anything to the 0 power is 1. So you really just have a 1 there. And then the negative goes along for the ride. So this answer is just -1, right? Anything to the 0 power is defined to be 1. Just put a 1. And the negative in the front just hangs out there. If that negative had been inside, just real quick, you know, if it had been like this, anything to the 0 power is 1. That wouldn't be -1. That one would be 1 because the negative's in there with the radical 7. All right, so that's the end of the power ones. Okay, for number 3, it only makes sense when you do 1 because you're only going to have 1 on your test. And it's going to look a lot like this one. Now you have 4 radicals to break down. Again, this is important. A lot of people, for whatever reason, you do it in your head or elsewhere, but you're not showing each step. There are certain steps in the process that I have to see as your work to justify what you are doing. The first is to break the radicals down into a product of smaller numbers. Now, 20 has to be 4 and 5. Why? Why not 2 and 10? You need a perfect square to come out of the radical, right? To come out of jail. So you break that down with 4 and 5. Now, 80 can be very tricky. I'm going to leave 80 for a minute. And I'm going to jump over to 45. 45 is going to be 9 and 5. And you should be seeing the pattern here. Both of these have a radical 5, right? 20 is 4 and 5, 45 is 9 and 5. I mean, what are you going to do, right? 45 with 15 and 3? 15 is not a perfect square. 3 is not a perfect square. You need a perfect square. So 9 has to be the number that goes into 45. The problem is there's a bunch of perfect squares that go into 80, right? 80 is divisible by 4. The problem with that is that it's not the largest perfect square. The radical will still be reducible if you use 4 and 20. 20 breaks down. I just broke it down. So you don't want to pick 4 and 20. You want to write this one with a 5. So the only way to do that is to have a 16 here. Now, if you're not sure how to do that, right? 80 is 4 times 20. but 20 is 4 times 5. So you do this on the side. And then look, 4 times 4, 16. You say, I can't do this without a calculator. Of course you can. You just have to do a little bit of work on the side. Keep breaking it down until you can't break it down anymore, until you get your 5. I know I need a 5. They all have to be the same. You can't combine them if they don't all have radical 5 left over. All the perfect squares are coming out of the jail. And then this is the important step that you show me. Too many people skip this step and you're going to lose points. 2 times, take them out of jail, it comes out of jail as a 2. This is why I should have had another number here. I should have had like, a 4 or something there. I don't like having the same number, but whatever. 16 comes out of jail as 4, radical 5. He's stuck, he can't come out of jail. 5 stays, radical 9 comes out of jail. Remember, these are products. I'm actually seeing people put pluses there. Here they do, all of a sudden they write 3 plus 4. I mean, where did this plus come from? If you don't see a plus there in the beginning of the question, like, if there isn't a plus, you don't go put a plus. So how are you changing it to addition all of a sudden? It's not. Quite a few people did this. Be very careful. The plus is here. Look, there's the plus. There's a minus, but this is a times. When there's nothing written there, it's multiplication. Radical 5 goes along to the right. Now multiply. 2 times 2 is 4. 4 what? 4 radical 5s. Negative 3 times 4 is negative 12. Radical 5 goes along to the right. 5 times 3 is 15. Radical 5s. It's not a coincidence. They all have the same number. If I want you to combine them all, and I do, what's the point of me giving you this question if I don't make them all go together into one thing? They're all going to have the same number. So now just add or subtract the numbers in front. Do the positives first, right? This is positive 4. So you get 19, take away 12, right? You have a positive 19 minus 12. That's 7. So you get 7 radical 5s. That's it. This is if any of these steps are not here, you will lose at least 1 point. So, if you don't give a damn, go skip all the steps. You're going to lose points, right? But I'm looking for, precision. I'm looking for all the work and justification to get here. If you jump from here to here, the second to last line, I guarantee you lose more than 1 point, right? If this question's worth, say, 3, you're going to lose 2. You have to show me all these steps. It's very important. All right, so that's the third one. Okay, question 4. All right, multiply the radicals. Squaring means you multiply it by itself. This is the very first step I have to see. I see you use that weird-ass formula that I talked about in class. You're going to lose points because you're not showing everything. You have to. There are four terms in this product. I have to see all 4 of them. Radical 5 and radical 5 is radical 25, right? Don't put radical 5 squared. Put radical 25. Radical 5 times 2 is 2 radical 5, right? That's the outer and the inner. That's the first and the last. Then I have to do the inner, which is 2 radical 5. And then I do the outer. 2 times 2 is 4. Right? One at a time, do it real careful, right? First, outer, inner, last. Do your little FOIL thing. This comes out of jail as 5. The 4 is waiting to hook up with them. You need to combine these together, right? They're like terms. They both have radical 5. Just add the numbers in front of them. Don't make this radical 10. Don't do nothing crazy, right? It stays the same. If you have 2 apples and 2 apples, you have 4 apples. You don't have 4 oranges. You don't have a different thing than what you started with. Now the 5 and the 4 you add together. Whoops. I don't like the way my 9 looked. Try again. Better. So 5 plus 4 makes 9. Now, here's the trap. I mean, man, it's so tempting to just add those together. 9 plus 4, 13. 13 radical 5. But it's not 9 radical 5 and 4 radical 5. It's $9 and 4 apples. That's not $13 and it's not 13 apples. I mean, these are completely different creatures. This is $9 and 4 radical 5s. You can't combine them together. It's tempting. You're going to want to. A bunch of people did it on the quiz, but you need to stop here. Now this one is a lot more complicated. You have a lot more stuff to keep track of. So again, I'll do. Let me relocate this. This time I'm going to do my little rainbow. I'm going to do my first. Keep track of this very carefully. 3 times 2 outside the jail, 6. Radical 3, radical 3. radical 9. First dude is done. Again, careful, slow. Now do the end. I have 3 times negative 3. That's negative 9 on the outside, and then radical 3 and radical 6 make radical 18. So there's my first outer. Now I'm going to do the inner. Put a 1 here if it helps you. Outside the jail is 2 times 1. That's a positive 2, right? Positive. Radical 6, radical 3, radical 18. Well, 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 look at that. Now do the end, right? The last. So again, you have a 1 times negative 3. That's negative 3. And radical 6 and radical 6 is radical 36. It's a lot to keep track of. Now again, I'm going to point out, I pointed out the same thing in class. This is important. Radical 18 is going to break down, right? 9 comes out of jail, 36, but radical 18 will break down, and you have 2 of them. They can combine. It makes no sense logistically, logically, in any way. It makes no sense to break this one down and then break this one down and then combine them. Why wouldn't you just do 2 take away 9, which is negative 7, radical 18s, combine them into 1? This is what a person does, right? A human being would do that. You know, the solvers see a radical 18 and they can't help but just start breaking them down over there, and then they combine them later. I'm not saying a person wouldn't do that too, but it looks suspicious to me when you don't combine them together. And it doesn't make sense for you to create more work for yourself. You're only going to get bigger numbers. You have to put them together anyway. Why not put them together first and then worry about that? So the radical 9 comes out of jail as 3. Minus now 3. Oh, look at this. Radical 36 comes out of jail. You get 18 here. You get negative 18 here. Yay! Now, I am going to start breaking 18 down just to save myself a step. 6 times 3 is 18. Negative 3 times 6 is negative 18. These are going to cross out. 18 minus 18 is 0. So all I was left with was this. So you start breaking it down, 9 and 2. Take the 9 out of jail as a 3. And now hook them up with the negative 7 that's there. So you get negative 21, radical 2. Much easier, much more straightforward than breaking this one down here, breaking this one down here. I don't see the sense in that. And I am all about common sense and, you know, logic. So those are those 2. You don't need to see a million of them because there's going to be more multiplying when I do the dividing, well, the fake ass division. Okay, question 5, the fake division, the rationalizing. I'm probably going to do one more. I did want to do A. I think I'll do it after I do these 2. These are the more complicated ones. You will have 3 of them on your test, and they are going to be worth 3 points each. Now, what I taught you to do was to multiply by the conjugate. So you write the exact same thing that you see, and you just change that sign. Very simple. It doesn't work to multiply by the same thing. That's going to fail. Now, on the bottom, you know, the top I'm going to multiply, but I'm going to do the bottom first, right? The bottom requires that you FOIL, right? Again, first, outer, inner, last. I want to see all 4. Radical 5 and radical 5 is radical 25. Radical 5 times negative 1 is negative 1 radical 5. 1 times radical 5 is positive 1 radical 5. And then 1 times negative 1 is negative 1. That's on the bottom. I have to see this. I'm going to say it really carefully. I must see that. If I see a number show up there, if I just see 5 minus 1 and 4, you're going to lose points. This is your work and your justification. You cannot skip this. I'm not letting you skip this. I will deduct a point if you skip this part. I have to see that you multiplied all 4 things out, and then you're going to get, 5 take away 1 on the bottom. Now on the top, really easy. Multiply this dude by both of them. 6 radical 5 times radical 5 is 6 radical 25. And then 6 radical 5 times negative 1 is 6 radical 5. Yay, not that difficult. Now, take everybody out of jail. On top, you get 6 times 5. Take away 6 radical 5. Be very careful here. All I'm doing is taking them out of jail. Radical 25 is 5. That's gone, that's gone. You have a minus 1. 6 times 5 is 30. Take away 6 radical 5. On the bottom, you have 5 take away 1, which is 4. Now, there's not a whole lot you could do here. You might be tempted to do 30 take away 6 and get 24. You're like, oh, 24 is divisible by 4. You cannot do 30 take away 6 radical 5. They are different creatures. This does not have a radical 5, so you cannot combine it with that. What you can do, though, since all the numbers are even, is cut them in half. Half of 30 is 15. Half of 6 is 3. And half of 4 is 2. The solver will make a huge mess of this problem and probably not even write it like this. But I don't care. This is what you get. You can't do anything else. Don't do anything else. What the hell else can you do? All I can do is just cut the numbers in half. They're all even. So I divide them all by 2. That's it. Right, again, multiply by the conjugate. Show the entire product on the bottom. Distribute the top carefully. Take everybody out of jail. Combine. Simplify. All right, that's it. Now, this one, I have to come all the way over here. The conjugate, again, you write exactly what you see. And you just switch the sign in the middle. I should have made that a minus, so this would be a plus. It's kind of lame, but whatever. It doesn't really matter. On the test, I would do that. I wouldn't have this one being plus and this one. This one would be minus, so the conjugate would be plus. I would switch it like that. Now, same thing as before. On the top, I have 10 times radical 8 minus radical 3. Now, I'm not going to mess with that yet. On the bottom, I have radical 8 times radical 8, which is 64. Radical 8 times negative radical 3. You have to be really careful here. This is negative radical 24. In the middle, right, the inner, you have positive radical 3 and radical 8. That's a positive radical 24. Whoops, I ran out of room. And then radical 3 times negative radical 3 is negative radical 9. Now, I want to point out a couple of important things. First of all, I know the solver won't do this way. Solvers do this in a real wacky, overly complicated way. You don't break these down, right? This is 4 and 6, but they're going to cross out. Don't even worry that this radical simplifies. You don't care. This goes away completely, and it's not there anymore. Now, radical 8, I am going to break down. Let me multiply with, you know what? I'll do it there, just to save. I should have did it in the first place. So you're going to do 10, right? Distribute 10 radical 8, take away 10 radical 3. This way I can break it down in the next step. On the bottom, though, I always do the bottom first. Radical 64 is 8, right? And radical 9 is 3. So I'm going to end up with a 5 on the bottom. And I have 10. I have a 10 there, so I know it's going to divide. Radical 8 is 4 and 2. Right? Start breaking it down. Now, just because I'm really limited in my space, this is 10 times 2, radical 2, right? Take the radical 4 out of jail as a 2, hook it up with that 10. I need to skip that step or I'm not going to fit this there. So I get 20 radical 2, right? Because the 4 came out of jail. The 10 radical 3 stays. And on the bottom, I have 8 take away 3, which is 5. Now, just like before, you're dividing this and you're dividing this. So, boy, this problem was really messy and nasty. 20 divided by 5 is 4. Radical 2 goes along for the ride. I mean, the answer comes out nice. 10 divided by 5 is 2, and the radical 3 goes along for the ride. And the answer comes out super nice. But there's a lot of places you can mess up within that question. So you have to be very, very careful. You do exactly what I did. I am aware that radical 8 breaks down. If you break it down at the beginning of that question, you are going to create double the work for yourself. And again, people don't do this. So don't do this. You do exactly what I did. I had to break the 8 down at the end on the top. But there was no reason to break this down because look, on the bottom, you just got 8 minus 3, which is 5. Why? It's so easy to do that like that. You don't need to worry about simplifying until the very end. You never break the radicals down until the end of the problem. Okay. So now I want to go back and do 5A real quick. Okay, so I decided to go back and do 5A just because I know that I have one like it on your test, and I want to make sure you all do it correctly. It's a pretty simple problem to start, right? When there's only one radical on the bottom, this is what you multiply by. right? You don't want to do nothing crazy here, nothing fancy. Just multiplying top and bottom by radical 6. Now on top, you're going to distribute, right? Boom, boom. So you put a 1 if it helps you. You're going to do 4 times 1 on the outside. Radical 6 and radical 6 is radical 36. Plus radical 6, radical 3 and radical 6 make radical 18. Now on the bottom, you have radical 6, radical 6. That's radical 36. Very straightforward. Now, start taking everybody out of jail. This is 4 times 6. 18 can break down with 9 and 2. I mean, this is a good question. There's a lot to this problem. Radical 36 is 6. Right? Radical 36 comes out of jail on the top and the bottom. 18, you're going to break down with 9 and 2. Then not now. So now do 4 times 6 on top. Get 24. Plus what? Radical 9 is 3. Comes out of jail. Radical 2 goes along for the ride. All over 6. Don't do nothing crazy and try to add those. It's 27. It's not. This isn't 24 radical 2, like I've said a million times already. Now, the only thing you can do, 24 is divisible by 6, right? You're like, oh, just divide them, you get 4. But what about this 3? That's the problem. You have a 24, a 3, and a 6. They're all divisible by 3. So you're going to divide every one of these numbers by 3. I mean, you can think of it as doing this over this over this, but don't. Because if you split this up into 2 fractions, this divides evenly and this doesn't. And it's going to screw you up. And you can't have your answer split apart like that. Your answer needs to be 1 fraction. So just divide everything by 3. Here you get 8. Here you get a 1. I'm writing it for emphasis. No, you don't have to write it. Divide this by 3. Right? Divide them by 3. 24 divided by 3, 8. 3 divided by 3, 1. 6 divided by 3, 2. You don't want that 1 there. It bothers you somehow and offends you. Don't put it there. But I'm putting it there for emphasis because 3 divided by 3 is 1. There you go. Done. But what about 8 divided by 2? You can do that. No, you can't. Leave it alone. There's a sum on top. You'd have to do this over this plus this over this. And again, as I say all the time, human beings don't do this. So you don't do this. No, I've never seen a student do that. So why would you do that? Leave it alone. You can't add the top and you can't divide anymore. So you stop. You're done. Okay. So that's the last dividing, the pseudo fake division. Now we have the complex number stuff. 6a. The temptation to just do -9 times -100. I mean, it's 900, but you can't do that. And besides, would you know that it's 30? 30 times 30. So multiplying negatives in the radical is undefined. Negatives are bad. Negatives in the radical are very bad. You have to take them out into the front. So remember I said, whenever you see a negative inside, you take it out into the front of the jail as I. And then you can free the guy from the jail. Now that comes out as 3 and hooks up with the I, makes 3I. This comes out of jail as 10 and hooks up with the I, and you get 10I. Now I'm going to multiply them together. 3 and 10 make 30. But what about the I's? I times I is not I. Right? It's just like X. X times X is not X. I times I is I squared. But this was defined for you. I squared is -1. So you must replace it with a -1. And then 30 times -1 is -30. So the product of those two crazy negative radicals in the beginning is -30. Right? I know I have this question in your test, so this is what I must see you do. There's nothing else correct. All right, now I'm going to do the last two. All right, the last two. Shudder to think how long this video is going to be. These are the last two that people asked me to do. I'm not sure why people were afraid of this one, but it's not that bad. Again, negatives inside the radical. This one doesn't have one though. So I'm going to take the negatives out in front as I. Right, that's step 1. Here I can just take the 4 out as 2. Right, free him from the jail. Over here, same thing. Bring the negative to the front. It's important. You do this in 2 moves. This is not a 1 move thing. First, you take the negative out. Then you break the square root down. So that comes out as 5 and hooks up with the I. 5 times 2 is 10. I mean, really, what the hell do you do? Radical 121 is 11. Hook it up with the I. Now, this is a complex number. And I told you, a complex number is written in the form real part, imaginary part, right? A plus BI. A is the real, B is the imaginary. So put the real part first, which is 10. You don't got to write the plus anymore. And now hook up the imaginary parts. You have 5i, take away 11i, you have 5 idiots minus 11 idiots. That's negative 6 idiots, whatever. I don't know what the hell, igloo, ice cubes. So this is the number written in standard complex form, the correct form, a plus bi, right? A plus bi, but it's minus. It's generic, right? The imaginary part's negative 6, the real part's 10. Very simple. Break the radicals down and combine the things you can. On the test, it's probably going to have 4 of them. I'll probably have one more radical without a negative that will combine with the 10, but it'll be something like that. Now the last one, easy multiplication. I don't want you doing FOIL with the i's. I want to just do a double. So it's easy to do. Just distribute. You get negative 14i, right? Treat the I like it's an x. It is a letter, right? It is a variable. I mean, it's not. It's a number, but you can treat it that way. So 2 times 8 is 16. And again, this is where you want to treat it like a letter. I and I is I squared. I mean, I know that I is the square root of negative 1. It's not a variable like x is and y, but it behaves the same way. The rules are the same. When you multiply 2 of the i's together, you get I squared. Now that's the problem. You can't leave this like this. Where the I squared is, you have to put negative 1. Now, where the I is, you do have to leave it because that's the imaginary part of the number. This is negative 16. Now, if you want to write the answer like this, I'm okay with it. But, some teachers are a little pickier. They want the answer in standard, proper, complex form, which is a plus bi. So this is the correct way to write it. I wouldn't deduct anything if you wrote it the way it is above. I don't care, whatever. I mean, you're supposed to write it this way. This is the standard complex form. So I'm not going to have a heart attack if you don't. But, this is so easy. Distribute, get I squared, replace it with negative 1. Done. I mean, there's nothing to say there. These questions are a gift on your exam. It's just kind of to give you some points on something easy. All right, so that's all the problems. Well, not all of them, but all the ones I'm going to do. So good luck as always.